Hey everyone, today we're gonna be doing a lead code question which is to find the smallest string starting from the leaf. So we are given some binary tree like this, having some character but in form it of a number. You can see here it is given like you are given a root of a binary tree having number in it from ranging from 0 to 25 which belongs to like A to Z. So you can say like 0 is mapped to A, similarly the 25 is mapped to Z. It's like 26 small case letters. We need to return the smallest lexicographical sorted string. So like we need lexicographical smallest string, or you can say this word from this tree starting from leaf. So they are asking the smallest string starting from the leaf. You mean like it is asking you to return in the reverse order. Not start from here, just start from backward. Now, so yeah, any constraint they are given like there can be like 1 to like 8500 nodes, and the value inside that node can go from 0 to 25, means a small case A to Z. So let's see with some example like how we can do this question with how we'll do this question, we'll see with some example. So let me draw the same tree. So we have some tree like A, B, C, and D. Okay, so we are given D and we are given E. We are given D here. We are given E here. So we have something like this in a string. Okay, we have this as our binary tree with this as a root. So what we wanted to do, we need to find the smallest string. So if I say very brute force approach, what we can do, we can start iterating, or you can say we can do a tree traversal. You can say a pre-order traversal, because we need a root, like we need to create our string starting from leaf. So if we say start, we need to like make our, like you can say, value or any string from leaf. That means we need to find the leaf first, which will be getting in a pre-order traversal. Like we'll get the node, like the least node, then we'll go left and right. Okay. So what I'll do a traversal over here. Like I'll say, okay, this is my current root. What I'll say, okay, go to left pointer. Now see, for this one, go to left pointer. See, after coming to this position, there is no left and right child. That means it is a leaf. So what I'll do, okay, when I get the leaf, I'll just return. What I'll say, every time when I reaches to leaf, I will be like storing some of the character. Like here, my character is passed as a. Here it will be passed as a B. Here it will be passed as a C or D. So what I'll say, okay, there will be some function. I'll say, okay, function where I will be having some root and I will be having some string. Okay, this is my string. Okay, so initially what I will be passing here, this will be my current root. Okay, this is my actual root, and this will be my empty string for like you can say for first run it will be empty. So if you see here, I have called this function like this function root comma single quote. I mean like it's an empty string. Now every time when we call this function for a left child and the right child, it will be called like this function root dot left, and you will be passing the character of this value. Like I'll say, okay, pass this value, like you can say root dot value plus our string. So if you see here, we need to find this root first. That means I need to append this character at the last. Every time I encounter any character, I just need to place in the front of the queue, or you can say front of the string. So my string started from here. I'll append this to the start. So here, if I say here, my string become like what? I pass initial string like this. Here it is like a plus a like this. For these two cases, I'll say okay. For this, it will be like b plus a, and for this, it will be like d plus ba, because every time it is like appending the node value to the string of this character. Okay. So what we can do, we can iterate and we can store all this all this node in a, like you can say, in a result array. So I'll say, okay, I will be creating some array. There will be some result array. I'll say, okay, there's some result array. It will be empty. Every time when I reaches to leave, every time when I reaches to leave, I will be like inserting my current path completely. So if you see, this is my path. I'll say, okay, dot append. You can say dot insert dba. So this is my recursive call. For this, it will be like uh, e eba. For this, it will be DCA, and for this call, it will be ECA. If you see, if I have this as an array, what I can do, I can now sort this array. So this is my very brute force approach. What I can do, I can store all the path, then I can sort this array. So I'll sort this array, I will get this as a minimum one. I can return something on the index 0 or the start element as my smallest lexicographical sorted character or string. But if you see, we have done the iteration and we have done this iteration in a linear time, but we have stored all the character which is done in the, like you can say, we use the stack size, or you can say height of the tree. We have used some k, you can say, constant for the length of a string that can also go at max to height of the tree. But if you see, we have stored all these occurrences which can be like 2 to the power n, because I, for each path I am just having two childs. So for that, like, I will be storing 2 to the power n, you can say path, or you can say string in my result array. So this is not optimized. What we need to do, we need to optimize this code further. So let me tell you one more thing. So if I say, for this, you can say this tree, for this A, B, D, E, C, E, I'm not given the character itself. What I'm given, like, if I say, if I take the tree again, I have this tree A, B, C, D, E, this D and E. So instead of this, I am given some values. So what I am exactly given, like, there's some value given like 0, 1. So I am just given the relevant, you can say, indexes for it. So I given here 2. For this also I given like 3. For this 4. For this 3. And for this 4. So I have given the indexes for the corresponding value. So for A, it will be starting at 0th index, B will be starting at first index, C will be starting at 2, and D, E will be starting at 3 and 4. So instead of character, I have given the indexes. Like in the question itself, if I tell you here, so this is an array, you can see here, this is an input, but we have given the input in numerical data. You can say number format instead of the character one. So we need to, like, map this as well for making it to a character. So what we can do, so if you see, I'll say, okay, my character will be starting from lowercase a. So I can do, like, I can append itself, like, I'll say, okay, create a new character. Okay, create character using a function called, okay, I'll use Python here. I can use char to create something on any specific number. So I'll say, okay, this is my ASCII code. So for this is my root value. Okay, this is my root value. But with this, I also need to pass what you can say, and you can say ASCII code for a character A, because it will be a starting character. So I'll say OCR, like ORD in Python, ORD, which give me the ASCII code of a small case A. So it will return something like 97 or anything like in the ASCII code, and it will be like um, adding with the current, you can say, current index. So if it is 0, my character will become A. If it is 3, it will be like ASCII code of A plus 3 means the D character. Okay, so it will be creating my character. But what we need to do, instead of storing, I need to do something which will be more efficient. So if you see, like, they are saying start you need to create a string from this leaf pointer, and you need to like store the minimum, not minimum, I'll say the smallest string. So what I can do, I can do a comparison between the child of particular parent. So what I can say, okay, for this parent, I don't have child. You can return simply D from here for this parent. So I'll say, okay, this parent have two child, D and D. I just need to take a smallest character or smallest string. So for this case, the smallest string is D. So for this parent, I got D as a minimum. I'll just append D over here. It will become DB. It will return DB. See, here it is having nothing. I'll say, okay, it will return empty string. For this also it will return empty string. Okay, this return the empty string. But now here it will return D because it is the only child. It will return what? E. Now here, if you see for this case, I'll say return me the smallest child of U. So what I can say, okay, D will be smallest. So it will return D from here, the minimum of both left and right. Okay, I'll say D return. I will append to my current value. I'll say, okay, D plus B is returned over here. Similarly, D return from here, D return from here. It become what? D, DC, because D is the smallest from D and D. It also become what? It become DB. Now, if you see between D and C and D and B, which is smallest? Here I am getting DB, I am getting DB here, and I am getting DC here. From this both, the smallest is DB. Okay, this is DB and DC. So I'll return DB from here. I'll append A because I'm at the current parent. So I'll say now my string become what? DBA, and this is the smallest because we are getting the smallest child. So anything written from here will be checked for each of the cases, and whatever string is coming to the lowest part will be returned to its parent. So what I need to do, like instead of storing all the child, like instead of storing all the string, I'll say I can just simply take the, you can say the current smallest character or the string in the particular run. So let me write the code for this, and I'll explain you how it is working. So for each time, I will be having some character returned, or you can say I have some string, okay, which will be returned from, I can say I will be storing the current character. You can say I'll say, okay, character of what? I'll say character of this current root dot value. So I have something, I need to create its value. So I'll say, okay, current root dot value will be like added, where it will be added to our, you can say character A. So I'll say, okay, ord of character A. So it will be creating my particular string, or you can say particular character. So this particular case will be creating my character for a particular root value. But let me do one thing. I will be doing some recursive code. So let me create a function. I'll say DFS. I will be doing a depth first search first. So I will be passing my root, and I will be passing some string. So initially it will be passed as what? I'll say, okay, I'll pass empty string here. So this will be returning from here. I'll say return what? DFS of root comma empty string. Okay, this is my main logic. Now whatever I do, I will doing over here. So each time when I'm like doing a call, I need to pass the parent's character, you can say. So this is my current node, or you can say this is my parent, and it is the character belongs to it. Each time what I need to do, I need to pass this to the next call. So okay, I'll say something I have received from parent every time. Initially it will be empty string. Okay, I will be appending my current character. I am just appending my current character to the string, like start to the string. So every time this is getting appended, and each time I will be doing some recursive call, like I will be checking if root having a left child and right child both. Okay, so I'll say if like a particular parent having both the child, I just need to find the minimum you can say minimum string. You can say the smallest string from both. So I'll do some recursive call. I'll say, okay, DFS, just find your left and right child. Just let me know the minimum string from there. So I'll say, okay, root dot left and same string and go and append and check. I'll say same do with the right child. Okay, so I'll do same with the right child. I have its right child. I'll do passing my current position or current string. I will be appending each character in the initial phase. If this is the case, return me the minimum, you can say minimum string from here. Else, what if I don't have the any of the child? So for first case, I'll say, okay, if I'm having only the left child. Okay, if I have only the left child, I'll simply return my DFS function. Okay, just check for the its left child. I'll say, okay, check for its only left child. Similarly, what if I just have my right child? So I'll say, okay, for right child, go and check only for your right child. I'll say, okay, go and check only for your right child. At last, I will be returning my current string, whatever I have created so far. So every time it will be like returning me this string at last, but I will be passing my current like appended string to overall strings. So if you see what I'm doing, I am just passing my current string, appending the character of a current node in the start for each of this recursive right and left call, and they will be returning me the string, the current string. Okay. So at last I will be getting my minimum string. So what I'll compile this code. Let me see if it is working fine or not. So this code works fine. Let me submit this code as well. And let's see if it is working completely fine or not. So it got accepted. And that's all for today's lecture. Thanks for watching.